So today we're continuing with evaluating limits. We did that yesterday. You had a homework assignment. It was all graphs. Okay. Today we're not going to see graphs. We're going to see tables and equations. Okay. So again, 3 ways to evaluate a limit graphically. We talked about that. Where is the y value as x is approaching a number, either from the left or from the right or from both? We're going to use 2 and 3. Using a table. If you have to create the table, it could take a little bit of time. So that's why table, it's rarely used. Okay. Using a table. See, I say it's rarely used, but sometimes we'll throw a table out there and you'll have to look at it and say, where is the limit approaching? Okay. Analytically, that's the one that you're most commonly going to see. That's the one we're going to spend most of the time on. Okay. Okay. So first thing, table. It says use your calculator, but you don't have to really use a calculator, or I'll use the calculator for you. So we're going to work with f of x when x is not equal to 0. Okay, so the first part, why is x not equal to 0 included in the function? Why is that necessary to include in the function? Yes. Yep. Plug in 2, it becomes undefined. So my question is, let's see, kind of a bonus question. Is it an asymptote or is it a whole? Well, x equals 2. So if I were to graph this thing on a graphing calculator or Desmos, would I see x equals 2 as a whole, or will it be an asymptote? What do you think? What do you think? See if we remember that from the other day. So what do we think? Whole or asymptote? What's the difference? That's my first question. If you know the difference, then it's an easy question. But what's the difference between, I know what they look like. One's a whole, one's an asymptote, right? One, let me draw it on here so the video will catch it. So if I draw a graph, so at 2, you have 2 options. That's an asymptote. That's a whole. Okay. So if it's an asymptote, more than likely, the graph is going to go up forever and ever and ever, or it'll go down forever and ever and ever, because it can't cross that. Okay. If it's a whole, there won't be that barrier. When the graph comes, it'll just be a whole. It's discontinuity. They're both discontinuity. They're both types of discontinuity because the point doesn't exist. Just like Arthur, right? Just like Arthur said, it doesn't exist. It's undefined. So that's right. But is it a whole or is it an asymptote? I'm not going to tell you. Yes. Yes, you're right. It would be a whole, but that's not the right reason. It would be a whole, not an asymptote. It would be a whole. Why? Why? So if you don't remember something and we talked about it before, what should you do? You guys are smart people. What should you do? So I'm not talking about calculus here, but anytime. Let's say we talked about something. Oh, I remember talking about that the other day, but I don't remember off the top of my head. What should I do? Look at your notes. Look at your notes, right? Look at your notes. It's on there. Or is it on there? Great. Yes, Shrishti, you had a hand up? When you factor it, yeah, the top you can factor. The top is difference of squares. One of the things you had on your summer assignment quiz, you had some difference of squares on there. It's difference of squares. It would be x plus 2 and x minus 2. The bottom would be x minus 2. Those would cancel out. So you're left with x plus 2. Okay? So there is no asymptote because once I cancel those out, there's no more denominator, right? There's no more denominator. So if there's no denominator, it can't be an asymptote. So it has to be a whole. Okay? So it's a whole there. So y is excluded because at x equals 2, there is a whole. Okay? On the test, they will ask you, is it a whole or is it a asymptote? Asymptotes are called infinite discontinuity. Wholes are called removable discontinuity. So asymptotes are either called, we'll talk about this later, but just as a pre-thing, if it's an asymptote, it's either called infinite discontinuity or sometimes it's called non-removable discontinuity. If it's a whole, it's called removable discontinuity. So they'll ask, which one is it? Okay. Okay, so table. So we're checking as the limit gets close to 2. So what they want us to do, in other words, what they're saying is they want us to find the limit as x approaches 2 for f of x. That's what we have to do. What is f of x? F of x is this guy right here. This guy right there. Okay? So you would have to use a calculator to do this. That's fine. I have a calculator. I'll do it real quick for you since you probably don't have a calculator handy. So I'll do it. So we're going to plug in each of these numbers into the yellow and see what we get. Okay, so 1.5. When I plug in 1.5, I get 3.5. 1.75. When I plug in 1.75, I get 3.75. Again, I'm plugging them into the yellow function, f of x. So I'm plugging it in on top, I'm plugging it in on bottom. I just have it programmed in my calculator, so it goes super fast. 1.9, I get 3.9. 1.99, I get 3.99. 1.999, I get 3.999. Okay? When I actually plug in 2, I get an error, undefined. Right? We said that earlier. Okay? Because of the hole. There's a hole there. There's no value. The value does exist, but it doesn't exist there. Okay? So what happens if I put 2.001 on there? I get 4.001. What happens 2.01? I get 4.01. When I plug in 2.1, I get 4.1. 4.25. 4.5. Okay. So that's what happens when I plug in all the x values into the function up here. That's what I get. So I created the table. Can you tell where the limit is? Can you tell what the limit is? Because we haven't answered that question, right? Let me move this down here. What is the limit as x approaches 2 by looking at the table? Well, what is a table? What's the definition of a table, the values? Heard somewhere. It's x and y's, right? It's x and y's, right? So isn't this the same thing as a graph? Just not dots, right? No dots. But these are dots, right? So essentially you're doing the same thing. Follow the path. The x's are getting closer and closer to 2, right? What are the y's doing? Getting closer and closer to what value? 4, right? Go the other way. As I'm coming from the positive side, the x's are getting closer and closer to 2. What are the y's doing? Getting closer and closer to 4. So because they're both getting closer and closer to the same number, we say the limit is 4. Okay, we say the limit is 4. Okay. You don't have to write this down, but I'll give you another example. Let's see. On Delta Math, they'll let you create the table. So, for example, so I can make this a little bigger so you can see it. So these are the types of problems you'll have, right? So we have to answer these questions. What is the limit as x approaches -5 from the left, -5 from the right, -5 overall, and what is the answer at -5? So we're going to put in numbers here. Okay, we're going to do the same thing. I'm approaching -5. That's where I need to, that's my middle. That's the middle, right? So I need to pick numbers that are left. So -7, -6. So I'm going to put in -7, -6, and then get closer and closer to -5. -5.5, -5.4, -5.2, -5.1. Oops, not 51. Oops, can't go back. Just don't look at that one. 5.1. Right? So it looks like a, oops, didn't hit enter. Oh, let's see, try 0.01. 5.001. Right? So what number does it look like I'm approaching from the left side, from the negative side? 4, right? It looks like I'm approaching 4. If I put another 0 in there, it's probably going to be closer to 4, right? Positive 4. Okay? So I would go down here and say from the negative side, my answer is -4. Okay? So now let me clear the table and go to the other side. So let me start with -2, -3, -4, -4.5, -4.7, -4.8, -4.9, -4.99, -4.999. So from the other side, the positive side, where does it look like I'm getting close to? 4 as well, right? Okay, I'm approaching 4. Oops, did I put -4 here? I should have put positive. Was it +4 or -4? Positive, yeah, so I was wrong, yeah. 4. If they're both the same, they're both approaching the same number, so it's 4. Now let me clear the table. How do I answer the last question? How do I know the answer at -5? Just plug in -5 to the table. Yeah, plug in -5. -5, just plain old -5, and you get -1 as an answer. So they're approaching at 4, but the answer is down here. So what type of discontinuity is that? It's a hole. Yeah, it's a hole. What if it was undefined? That means there would be a asymptote. Okay. But yeah. Okay. So that's the type. It's the same thing, it's just done electronically. Okay, done through the table. So that when you see that in your homework assignment or your class assignment, that's what you do. So the table's not too bad, right? The table's not too bad. And most of the time they won't make you create your own table because you can't use a calculator. This is non-calculator stuff. So you can't, I mean, you could, but you'd be wasting your time to do all of this stuff, make this table without a calculator, right? So most of the time what they'll do is they'll give you table. Easy way to create a table, or they'll give you the table, but you have to be able to see. Okay, you have to be able to see where to look. Okay. All right. So the next one, algebraically. So this, now they're not going to give you a table. They're not going to give you a graph. They're going to give you an equation or a function. Okay. So how do we do it? Well, there's 5 steps that I usually follow. There's others too, but first one, plug it in. If you get a value, that's your answer, move on. Plug it in. If you get an answer, that's your answer, move on. Okay? Unfortunately, that won't happen a lot. Okay? Probably on your test coming up in a few weeks, that you won't have one like that easy. Okay? You might have a few like that on your assignment, but it's just not that easy. Okay? So what else do you do? Well, one thing you could do is factor. If you can factor. Common denominator, combine things. Combine things using addition or subtraction. Multiply by the conjugate. We'll talk about the conjugate. If you don't know what the conjugate is, we'll talk about that in a second, or other methods. There's other methods you have to do too. Okay? So if direct substitution's A, plug in, chug. That's direct substitution. If that yields a fraction with 0 in the denominator and something other than 0 in the numerator, so a non-zero number over 0, then it's DNE. Okay? So if that happens, if it's 0 over 0, we still got work to do. 0 over 0 is not the same as something over 0. Okay? 0 over 0 is not the same as a number over 0. One is what we call indeterminate value, and one is undefined. Okay? Okay, this doesn't really fit. I wish I would have put it in yesterday's, but it doesn't really fit. It's when do limits not exist? We've seen one already, right? When it doesn't approach from the same side, when they're do this thing, right? When one increases and one decreases, so they don't meet. So number 1 and 2 pretty much just say when they don't meet. 3 is another one, oscillates. Oscillates is repeats, right? If it oscillates like this, what goes like this? What does this? Sine and cosine waves, right? Sine and cosine waves, those oscillate. Okay, so things like that, things that repeat. Oscillating means oscillating fan means it repeats. It goes one way, comes back the other, right? Oscillate means oscillates between 2 fixed values as x approaches c. So if it keeps repeating itself, that's a DNE. Okay. All right. Okay, so let's look at the first one. Here's kind of a flow chart. We'll come back to the flow chart. It's a helpful flow chart, but not yet because we haven't really gone over all of these. It's more come back to it. Okay, so let's look at example number 1. Example number 1. They don't give you a lot of room on example number 1. It's a reason why, right? First step, plug and chug. Check if you can plug and chug. If you can do that, you're the luckiest person on earth. Move on to the next and get an answer, move on. Let's see if we can do it. So plug in 2. So I get 4 over 10, which equals 2/5. That's a number. 2/5 is a value. I'm good. I'm happy. Move on. The limit as x approaches 2 is 2/5. Okay. So that's one of the rare ones where you're like, plug in, it works. Good. Okay. Letter B. I have to find the limit. So I have to find the limit as x approaches. X approaches 2 of f of x. Well, what is f of x? What type of function is f of x? It's piecewise. It's got 2 pieces, right? When does it change from one function to the other? when does it change from one function? Like if I'm plugging in values, like if I was plugging in x's and y's, right? When do I decide which one I'm going to use? Which function I'm going to use? Which piece I'm going to use? Yep, any number bigger than 2, I plug into the top. Any number that's 2 or less, I use the bottom. So where does it change? When do I change functions I'm using? At 2, right? Lo and behold, that's the one they want me to use. That's the one they want me to use. Okay. So if I wanted to check where it was from the left, coming from the left, which one would I use? The top one or the bottom one? Bottom, because those are the numbers that are less than 2. If I was coming from the right, I would use the top because those are the numbers greater than 2, right? Well, what's our first step? What's our first rule for finding limits of these guys? What's our first rule? What's our first rule? If you don't remember it, where should we look? In our notes, straight down. What's our first rule? First thing we should always try. Plug it in. Plug it in. Try that. If it doesn't work, move on. Which one am I going to plug in 2 for, though? Yeah, the bottom, right? That's when it equals 2. The top one doesn't equal 2. It's everything after 2. 2.01, 2.001, 2.1, 2, all of those numbers, right? So the limit as x approaches 2, I'm going to use this guy right here. Oops. So I plug in 2. I get 4 minus 9, which is negative 5. That's a number. I'm done. I'm done. Hey, Roman, come on in. There you go. Okay. I got a value. I'm happy. Okay. You want to stay for calculus, Roman? No? Okay. Move on. Okay. So that one was, I don't want to say easy. I hate using the word easy, but you just had to know which one to plug it into. If I plugged it into the top, I would have been wrong because that's not 2. That doesn't fit 2, right? That's everything bigger than 2. Okay. All right. So now let's get to the good stuff here. All right. Plug and chug. Go. See what you get. Plug in -1. What do you get? No calculators. I use a lot to use calculators. So you can do it by hand or you can do it by in your head. So when I plug in -1, what do I get? Well, what type? Which one? Is it 0 over 0 or number over 0? You got a number? It should be 0. It should be 0 over 0, yeah. Yeah, if it was a number over 0, D&E, move on. But I believe this one is 0 over 0. That's not undefined. That is a what's called an indeterminate. It's called indeterminate because I don't know what it is. Is it undefined or is it 0, right? The rules for undefined said if I have a 0 on bottom, it's undefined. It does. But if I have a 0 on top, isn't that equal to 0? So is it 0 or is it undefined? I don't know. That's why it's called an indeterminate form. Okay. That means we got work left to do. We got work left to do. So let's go back up to the top. Let's look at our methods. I tried method A, didn't work. Factor. Can we try to factor this guy, see if it works? Is there a way to factor letter C? You better be saying yes because it was on your summer assignment. You had to factor on your summer assignment and your summer assignment quiz. How do I factor the top? I can't factor x out of the top, just the top. I'm just focusing on the numerator. How do I factor, let me highlight it. How do I factor this guy here? Hey, come on. Oh, from the library? Thank you. Okay. How do I factor the top? Should put these back up. It's a trinomial. If it's a trinomial, set it equal to 0. Well, there's no equal signs, so I don't need to set it equal to 0. Factor out a GCF. So is the top. Does the top have a GCF? I'm just focused on the top. Don't worry about the bottom right now. Does the top have a GCF? Nope. Move on. A, B, C. So what's A, what's B, what's C here? A is 2, B is -1, C is -3. Okay? Multiply A times C. All right, so we're going to use our little diamond thing, which you guys have used, I'm guessing, many, many times before. Multiply A times C. You said A was 2, you said C was -3, so that's -6. B is -1. So what are the two numbers that multiply to be -6 and add to be -1? -3, +2. Okay, so now let's go over here. So we have A, the last term, we said -3x and +2x. So both of these guys need an x. So this one's going to get a 2 since I can do a +1 there, and then this guy's going to get a -3. So I get 2x - 3 and x + 1. Factored. See that step right there? What I just did, that had nothing to do with calculus, right? That's what the summer assignment is for. Because the quicker you can do those things, the easier calculus will be. Because if you let this stuff bog you down, by the time you get to the calculus, you'll be done. You'll be like, I'm done. Yeah. So the quicker you can do these prerequisite steps, the quicker, the easier your problem will be. Okay. X + 1. X + 1's a binomial. X + 1's a binomial. So set it equal to 0. There's no equal sign. Does it have a GCF? The bottom, the denominator. Does it have a GCF? The pink purple. Does it have a GCF? Besides 1? Nope. Move on to the next step. Difference of squares. Is it difference of squares? No, because there's no square and there's no difference. It's a plus. Okay, so we're done. Leave it alone. X + 1. Yeah. That's my next question. I can now cancel them out because they're factored, right? That's going to create a hole at -1. It's going to create a hole at -1. Yep. That's what's left, right? Once I do that, now go back and plug and chug. Can I get an answer if I plug and chug now? Or will I get undefined again? Or will I get indeterminate? Nope, I get an answer, -5. Right? We always go back to plug and chug. So anytime you do any of those steps and you factor something out, then go back to plug and chug. Okay? We always go back to that step. Okay, so the limit is -5. And yeah, like Arthur said, there will be a hole at negative, or at what was it, -1? There will be a hole at -1. That's important. Yeah. Didn't ask us in the question, but it's good to know. Okay. All right, let's go to the next one. Let's go to the next one. Letter D. Plug in. Okay, see what you get. Plug and chug. You can do it in your head if you can. If you don't want to, sometimes you can do it in your head. If you want to do it on paper, you can. Just no calculators. What do you get when you plug and chug? What do we get when we plug and chug? What am I plugging in first? 0. Yeah. Plugging in 0. Everywhere I see an X, 0. Zeros are nice because they cancel everything out, right? So what do you get on top? 0. What do you get on bottom? 0 plus 0, which is 0. All right. 0 over 0 means we have work left to do. We can't move on. Okay. What can we do? Can we factor this? Can I factor either the numerator or the denominator? Yeah. Which one can I? Shrishti, which one can I factor? The denominator. I can factor. It's a binomial, and it's got a GCF. So let's try that. Okay. So the limit as x approaches 0, the top is just 2 times x. It's a monomial. But the bottom is x, and then when I take that out, it's going to be x plus 4, right? What factors out? Will anything factor out? The answer is yes. Something will factor out. What will factor out? I heard it somewhere. X, yeah, the X here. This is a lone wolf X. This is a lone wolf X. The only X that won't cancel out is the X on the inside because that's not a lone wolf. That's a binomial. They go together. Okay? But those X's will. So let's see what I have left. We will have a hole though. Bonus question, where will the hole be? Because something factored out. That means a hole. Where would the hole be? Not a 2. 0. Yeah, 0. Because just like we did here, we knew that it was at -1 because that was the 0 here, right? Because x plus 1, I plug in 0, I get -1. But what about here? It's just x. So what is it really? X plus what? 0. 0. So that's a 0. So let's write that down. Hole at x equals 0. Okay. So what do we got left when we do that? We get 2. Actually, no, I shouldn't write it like that. The limit as x approaches 0. Now it's 2, and then x plus 4. That's what's left, right? Plug and chug, see what we get. Get 1/2. 1/2's a number. We're good. We're good to go. 1/2 is the answer. Okay. All right. Let's look at letter E. We're going to crank it up just a little bit. Crank up the temperature just a little bit on here. Okay, so in your head or on paper, plug and chug. Can you do it now? What do you get when you plug in 3? If you can do it in your head, great. If you can't, don't worry about it. Do it on paper. Yes. We get a 0 over 0, right? That means we still have some meat left on the bone. We still have work to do. We can't just go on to the next one and say undefined or DNE or something like that. We get 0 over 0. Okay, so let's go back to our steps. Step 1 said plug and chug, or plan A was plug and chug. That didn't work. The next one says factor. right there. Factor. Can I factor this guy? The answer should be no. You can't, anytime you have a square root, you can't factor. Factoring is not an option if you have a square root. If you have x squareds and x thirds and x fourths, then maybe factoring is an option. But factor, you can't factor if you have square roots. That's not an option. Okay, so we got to go to the next one. Common denominator. Common denominator is like when you have two fractions that you can add or subtract. I only have one. There's only one fraction. This is one big fraction. So there's nothing I can add or subtract there. Okay. The next one says something called multiply by the conjugate. That's what I'm going to do. That's what I'm going to do. I'm going to do multiply by the conjugate. Okay, so what is the conjugate? You might have heard the term before. Conjugate is a binomial that's has a different sign. Okay, so I'll give you some examples. So a conjugate. So for example, x plus 2 and x minus 2 are conjugates. 4x minus 6, 4x plus 6 are conjugates of each other. They're exactly the same, except they have a different sign in the middle. It's kind of what comes from difference of squares, right? It's usually it's the end product of difference of squares. So when we do this, we're going to focus on the part that we're always going to focus on the root. We're going to focus on the root because I want to get rid of that root. Okay, so we're going to multiply by the conjugate of the top. The conjugate of the top. So this is going to look like. Okay, so we have our regular x plus 1 minus 2, and then x minus 3. Okay, so we're going to multiply by the conjugate of the top. So what is the conjugate of the top going to be? Close. You're close. You got one of those right. Yes. So no, this part's going to stay because this is the first term. That term stays the same, right? The second term stays the same. What's the only thing that changes? The sign in the middle. The sign in the middle. So that's going to become, let me change the color. That's going to become a minus. Or sorry, plus. Sorry. When we multiply the top of a fraction, what's the rule? If we multiply the top of the fraction, what else do we have to do? Because otherwise you're changing the fraction, right? So we have to multiply the same by the bottom. So we're going to do the same at the bottom. Okay. So what this is going to result in is this. Square root of x plus 1 minus 2. Square root of x plus 1 plus 2. And on the bottom, you're going to get x minus 3 and square root of x plus 1 plus 2. I probably should have used red, but oh well. Okay, so we're going to do this piece by piece. Look at the top. Look at this top part. Does that look familiar? They're conjugates of each other. Besides that, they're very close to each other. It is difference of squares, right? I kind of mentioned that earlier. These are all difference of squares of each other. They're difference of squares, right? So difference of squares it's a squared minus b squared. That's what difference of squares are. I don't want to have to multiply those two guys because those two multiplication, it's going to be ugly when I multiply them. Because if I were to multiply them, I would multiply, I'll write it on the board. I don't want to write it here, but I would write it like this. I would have to do a 2 by 2. And then it would be the first term minus the second term. And I would have to multiply these two guys together, these two guys together. That would be ugly. I mean, I could do that, but it actually, you know what? It might be easier to do it that way. Might be easier. It'd take a little bit of space, but it might be easier. Let's see. Okay. So what I'm going to do is I'm going to multiply the top, the yellow, just like I did on the board. Minus 2 square root of x plus 1 plus 2. I'm just multiplying the yellow. So multiply like a multiplication table. X, the square root of x plus 1 times the square root of x plus 1. The square root of x plus 1 times the square root of x plus 1. What do I get when I multiply those two? Yeah, easy, right? X plus 1. Because it's the square root of x plus 1 squared. So the square root goes away. Next one. What do I get when I multiply negative 2 times the square root of x plus 1? Exactly. Negative 2 cannot multiply with x or plus 1 because does not have a root. This guy doesn't have a root. This guy has a root. So I just write negative 2 square root of x plus 1. Same thing with the bottom. Instead of a minus in front, it's a plus in front. And then negative 2 times positive 2, negative 4, just a regular negative 4. Okay. Now let me combine like terms here. Let me combine some like terms. Move this over here. So when I combine like terms, the limit as x approaches 3. So let me combine some like terms. I have x, just one x by itself, so I got to put an x. And then I have a plus 1 here and a minus 4 here. So when I combine those two, I'm going to get x minus 3. What about in the two boxes that I didn't? What's going to happen to those two boxes? They're going to cancel out. Yeah, because if I add them together, all I'm doing is adding the coefficients because they're both like terms. So plus 2 minus 2, 0. So all I'm left with is that. Now, let me write down what I wrote down on the bottom. The bottom, I'm not going to multiply yet. I'm going to see if I don't have to, because that one is even worse. I haven't multiplied the bottom yet. There you go. X minus 3's can cancel out. I'm left with a 1 on top. So let me rewrite what I got. The limit as x approaches 3. The only thing I have on the bottom is the square root of x plus 1 plus 2. Plug and chug. Do I get an answer when I plug it in? Let's see. 3 plus 1 square root plus 2. Square root of 4 is 2 plus 2, 1/4. Yep. Anytime you do these types of problems, you'll always get a fraction as an answer too. That's one way. So if it's like a multiple choice question, 2 of them might be fractions, 2 of them might not be fractions. For these types of problems, you almost always get a fraction. So you can just like cancel those, cross those out, and just focus on the fraction parts. Okay? Now, this part right here, before we go on, this part right here, this part underneath that you can see on my screen, that part had nothing to do with calculus right there. That's nothing to do with calculus. That's algebra. Okay? You want to know the calculus part? Right there. That was the calculus part. The easy part was the calculus part, right? Again, this is where students struggle. They don't struggle with the calculus part. They struggle with the algebra part. Having good algebra skills, right? So if you have good algebra skills, you'll be fine. If you don't, that's something you need to beef up on, okay? Again, that's the reason for the summer assignment and the quiz, because I want to make sure that your algebra skills are where they need to be, because that's where students struggle. It's not with the calculus part. Finding limits is not too bad, but it's getting there, right? That can be the issue there. Okay, we'll do last one. We'll do last one for today. This last one on the paper too, right? Yep. Good. We'll do some practice tomorrow. We'll have time to do practice. Today we've been doing them together. Tomorrow I'll get some problems and let you guys work on your own. Okay. Okay. So here we go. It's got a fraction, minus a fraction, over a fraction. Plug and chug. So plug and chug. If you haven't already, try it. Plug and chug. See what you get. So when you plug in 0, everywhere there's an x, you get 1/4 minus 1/4 with a 0 over 0. 0 over 0. Still got work left to do. That means we're not done yet. Okay. Step 2 said factor. Well, I can't really factor anything because there's now no x squareds, x cubes. That's usually the key when there's x squareds and x cubes and stuff like that. These are all x to the first power. They can't be factored. Conjugate. There's no roots. Anytime there's roots, that's when you want to focus on the conjugate. So the last step is combine common denominator. Get things together, bring things together. So what I'm going to do here is I'm going to combine these two guys right here. How am I going to combine them? Using subtraction. They're both fractions, and there's a subtraction sign in between them. So that means I can subtract them. Okay. Again, now what I'm about to do was on your summer assignment because it is important. This skill that we're going to do right now is extremely important. So I got 1 over x plus 4 minus 1/4. I'm just focusing on the top. What do you need when you subtract? What do you need to subtract fractions? All right, common denominator. Okay, so I have two denominators. This guy and this guy. What is the blue guy missing and what is the purple guy missing? Don't say X. Yeah, Trishti? There you go. Thank you. The blue needs a 4. Well, you're like, wait, doesn't it have a 4? No, it doesn't. It has an X plus 4. X plus 4 is not the same as 4. X plus 4 is a number plus 4. This guy needs a number plus 4. Okay. So let's simplify this. Limit as x approaches 0. So now it's 4 over 4x plus 4 minus 1x plus 4 over 4x plus 4. The bottom is x. Common denominator now. Once I have common denominator, what do you do? How do you subtract them now? What's the rule for subtracting once you get a common denominator? You did the hard part. What's the easy part? Subtract the tops, right? Subtract the tops. Okay? But before I can subtract this top, I got to distribute. It's a minus, so it's minus everything. So when I distribute, it's actually a -1. It's actually a -1. So it's going to be 4 minus 1x minus 4 over 4x plus 4. Fours cancel out because one's a positive, one's a negative. So now I have the limit as x approaches 0. I have a negative x on top, a 4x plus 4 on the bottom, and an x on the bottom. Plug and chug. If I plug in 0 now, will I get an answer? Or will I get 0 over 0? If I plug in 0 on top, everywhere there's an x, I plug in a 0. What do I get? It's still 0 over 0, right? That means there's work left to do. We still have to do some work. Okay, so once I did that, now I have a fraction divided by a fraction on top and then division right there, right? So I'm going to rewrite it. That's what it says, right? I just wrote it differently. What's the rule for dividing by fractions? Multiply by the reciprocal of the second one, right? So instead of divided by x, it's going to be times 1 over x. Now, when I do that, what happens? The x's will cancel out, yeah. This guy goes away, that guy goes away. So I still have a -1 there. So I have -1 on top, and then 4x plus 4 on bottom. Plug and chug. See what you get. Done. Okay. Again, calculus part was right here. Plug and chug. Calculus part was right here. Plug and chug. Calculus part was right there. Plug and chug. Everything in between had nothing to do with calculus. That's algebra. That's math 1, math 2, math 3. Okay? So make sure that's one of the things we got to make sure on. Okay? Before we do anything, that's one of the things, because you're going to see these a lot. Okay, so tomorrow we're going to do some practice. I'm going to give you some time to do some of these practice problems on your own, and then I'll let you guys start on the assignment. Okay? So no new assignment. Just make sure if you haven't done the other assignment, make sure you get it in by tomorrow.